Good day everyone, and welcome to where we are putting together solutions to those math and science areas that students are getting. In this video, we'll be looking at CSEC Mathematics, and specifically the combined topics of algebra, relations, functions, and graphs. This question appears in section 2 of paper 2, and this video looks at 5 years past papers from May 2014 until 2018. Don't forget to like the video and add any comments down below so we can help by creating other videos in whatever areas that you are struggling with. We've also put in the description down below the order we suggest to go through the entire CSEC Maths syllabus so you can get a better grasp of the entire subject area. As we look at the 10 major topics in CSEC Mathematics, this video looks at topic number 6, Algebra, and topic number 7, Relations, Functions, and Graphs. Both these questions appear individually in section 1 of the paper and appear combined as one whole question in section 2. This video looks at the question that appears in section 2, which comes as one full question with 12 marks out of 100. Some major topics that appear within this includes quadratic equations, simultaneous equations, linear programming, speed-time graphs, and we've looked at the past paper questions which have appeared every year for all 5 years from 2014 until 2018. May 2014, number 9a, two functions are defined as follows: g of x equal to 4x plus 3, f of x equal to 2x plus 7 over x plus 1. So we can see this is a relations and functions question. Part 1, state the value of x for which f of x is undefined. So if we look at the function f of x, for it to be undefined, it means that it's impossible to get a value. And the only way that can happen is if the denominator works out to be 0. And because we know any number divided by 0 is undefined. Let's put the denominator x plus 1 equal to 0. As such, x is equal to minus 1. Part 2. Calculate the value of g f of 5, this composite function. So, if we're looking at g f of 5, the first thing we're going to look at is f of 5. Let's rewrite the function f of x equal to 2x plus 7 over x plus 1. And if we substitute in for x, we'll be replacing it by 5. So f of 5 is equal to 2 by 5 plus 7 over 5 plus 1. Remember, we're replacing x by 5. So 2 5s are 10 and 7 17 over 5 and 1 6. Since f of 5 is equal to 17 over 6, we can now replace the composite function by g of 17 over 6. Because 17 over 6 is f of 5. So let's write the function g of x equals to 4x plus 3. So g of 17 over 6 is equal to 4 by 17 over 6 plus 3. And 4 by 17 is 68. 68 over 6, if we divide by 2, is 34 over 3 plus 3. That's 34 plus 9, 42 over 3. As such, g f of 5, the composite function, is equal to 43 over 3. Part 3 of the question, find f inverse x. So we want to find the inverse function of f. Let's write f of x is equal to 2x plus 7 over x plus 1. And if we bring the denominator across, we're going to get x plus 1, let's put it in brackets, times f of x is equal to 2x plus 7. And if we expand it, then we get x by f of x plus 1 times f of x is f of x. We don't need to write a 1, is equal to 2x plus 7. So let's bring all the x's on one side. So we get x f of x minus 2x is equal to minus f of x plus 7. So we can factorize out the x. So we get x by f of x minus 2 is equal to minus f of x plus 7. So we can carry that across. So we're left with x is equal to minus f of x plus 7 over f of x minus 2. And now we just replace x by f inverse and replace f of x on the right side by x. So f inverse x is equal to minus x plus 7 all over x minus 2. May 2014, number 9B. A ball is thrown vertically upwards. Its height, h meters above the ground after t seconds, is shown in the table below. So we can see the table runs from time 0 seconds until 6 seconds. And the height at 0 seconds was 0, meaning it was on the ground. The ball went up in the air, so the height increased until a maximum of 90 meters and then decreased until it hit the ground again at 6 seconds. Part 1. Using 2 centimeters to represent 1 second on the x-axis and 1 centimeter to represent 10 meters on the y-axis, plot a graph to show the height of the ball during the first 6 seconds. So let's bring up the graph. And if we look at the major lines, let's consider that if you're looking on the x-axis, that each one of those major or darker lines is 2 centimeters. So following the scale, 2 centimeters represents 1 second. Then we have 0, 1, 2, 3, 4, 5, 6 seconds. And on the y-axis, 1 centimeter represents 10 meters. So our major scale there is 2 centimeters, would represent 20 meters. So we have 20, 40, 60, and so forth. And if you want to plot our graph, let's put in the values. When time is 0, height is 0. And when time is 1, height is 50. Time is 2, height is 80. 3, 90. 4, 80. It's coming back down. 5, 50. And 6, 0. It hits the ground. So we can connect these points. Part 2. Using your graph, determine part A, the average speed of the ball during the first 2 seconds. So average speed will be the total distance covered over the total time. And after 2 seconds, it covered a distance of 80 meters over a time of 2 seconds. 20 80 is 40 meters per second. And part B, the speed of the ball when t is equal to 3 seconds. The speed in a distance time graph is the gradient of the graph at any point. So at t is equal to 3 seconds, where it's a maximum, the gradient of the graph, let's draw a red line to indicate that. And we can see that's a flat line. So the gradient, which is the speed, is 0 meters per second. May 2015, number 9A. A teacher marks an examination out of a maximum of 120 marks. The marks are then converted to percentages. Part 1. Calculate the percentage from a student who scores 60 marks. So that will be 60 out of 120 times 100 to convert it to percentage. 60 into 120 is 2, 2 into 100 is 50%. And if a student got 120 marks, that will be full, all the marks possible. It will be 120 out of 120 times 100. 120 cancels, so we're left with 100%. Part 2, plot a graph to show the information in part 1. So let's bring up the graph. Let's put marks on the x-axis from 0 to 120. And let's put the percentage up to 100% on the y-axis. And let's bring in the point at 60 marks. It was 50%, which we just worked out. And at 120 marks, it's 100%. And of course, if the child got 0 marks, then that is 0%. Let's draw a long black line through all of those points. So we've just plotted the graph. Part 3. A candidate is awarded 95 marks on the examination. So where do we get marks? On the x-axis. Use the graph drawn at part 2 to determine the candidate's percentage. Draw lines on your graph to show how the percentage was obtained. So if we go to the x-axis, look at where 95 is and draw a red line going upwards until it hits the black line. And when it hits that point, we go to the left until it goes to percentage. You notice we're putting arrows on it so that you could easily see the direction we went. Then it reads off at 79%. Part 4. A candidate is awarded a grade A if her percentage is 85% or more. Use the graph drawn at part 2 to determine the minimum mark the candidate needs to be awarded a grade A. Draw lines on your graph to show how the percentage was obtained. So if you're looking, they're giving us percentage. So let's go to 85%, and that is on our y-axis. And let's draw a line going across in green, the arrow at the end showing that we're moving to the right until we hit the black line. And then we come downwards, and that will tell us our mark that's required. That mark and anything above that will give us a grade A. So the minimum mark required is 102 out of the 120. May 2015, number 9B. two functions f of x and g of x are defined as f of x equal to 3x plus 2, g of x equal to x squared minus 1 all over 3. Part 1. Evaluate g of 5. So they want us to find out in the function g of x, when x is 5, what does that work out to be? So let's write the function g of x equal to x squared minus 1 over 3. Let's substitute. G of 5 is equal to 5 squared minus 1 all over 3. 5 squared, 5 5s are 25, take away 1 is 24, 3 into 24 is 8. Part 2. Write an equation in terms of x for f inverse x. So f of x, that function is 3x plus 2. And if we want to find f inverse x, let's first of all make x the subject of the formula. So let's move the plus 2 across. So it will give us f of x minus 2 is equal to 3x. So x is equal to f of x minus 2 all over 3. Now let's rewrite it into the form that we want. Let's change the f of x to x and change x on the right hand side to f inverse x. So x minus 2 over 3 is equal to f inverse x. Part 3, write an expression for g f of x, that composite function, in the form x plus a by x plus b, where a and b are real numbers. So g f of x, that's what we want to find. So let's first of all find f of x. And we're given that f of x is equal to 3x plus 2. So we can replace g f of x because we know what f of x is. So that is the same as finding g of 3x plus 2. And let's write the function g of x is equal to x squared minus 1 all over 3. And let's substitute. Instead of x, we're having 3x plus 2. That's what we want to find. So g 3x plus 2 is equal to 3x plus 2 squared, because we're replacing x by this new brackets, minus 1 all over 3. And all we need to do now is work out that right hand side. 3x plus 2 squared means 3x plus 2 times 3x plus 2 minus 1 all over 3. You can use FOIL to expand it, and we're going to get first term by first term, 9x squared, outer term by outer term will give us 6x, inner term by inner term plus 6x, last term by last term, 2 2s are 4, minus 1 all over 3. And if we simplify that, we will get 9x squared plus 6x plus 6x is 12x, plus 4 take away 1 is 3. 9x squared plus 12x plus 3 all over 3. And we can factorize from the top, we can take out 3. So it will be 3 times 3x squared plus 4x plus 1. And we could double check that 3 by 3x squared is 9x squared, 3 by 4x is 12x, 3 by 1 is 3, all over 3. And now what can we do? The 3 on top and below can cancel, so we're left with 3x squared plus 4x plus 1. And we can factorize that, and that's going to give us 3x plus 1 by x plus 1. So g of f of x has been written in that form as suggested above. May 2016, number 9a. The functions f of x and g of x are defined as f of x is equal to 2x minus 7 and g of x equal to x squared plus 1, respectively. Part 1. Write an expression in terms of x for each of the following. F inverse x. So if f of x is equal to 2x minus 7, then let's make x the subject of the formula. So you're going to get f of x plus 7 is equal to 2x. And we want x alone on the right hand side, so we have to get rid of the 2, which is multiplying. So when you bring it across, it will divide. So we'll get f of x plus 7 all over 2 is equal to x. So let's rewrite it. So we get x plus 7 all over 2 is equal to f inverse x. Fg of x, so that composite function. So let's first find g of x, which is x squared plus 1. And we can rewrite f x squared plus 1 as we replace g of x by that. So let's write the function f of x equal to 2x minus 7. And we want to find f of x squared plus 1. So we're replacing x by this new term, x squared plus 1. So that will give us 2 by x squared plus 1 minus 7. So that's 2x squared plus 2 as we expand the brackets, minus 7. And that is 2x squared plus 2 minus 7 minus 5. As such, the composite function fg of x is equal to 2x squared minus 5. For the third part, find g inverse x. So if g of x is equal to x squared plus 1, we want to find x alone on the right hand side. Let's make that the subject of the formula. So g of x minus 1 is equal to x squared as we bring the plus 1 across. And we want x alone, get rid of the square on the right side, so it becomes square root. So it will be g of x minus 1, the square root of that is equal to x. So we can rewrite it, and we get in square root of x minus 1 is equal to g inverse x. For the fourth part, find fg inverse x. Now, fg of x is equal to 2x minus 5. We found that previously. And if we want to find the inverse, let's make x the subject of the formula on the right-hand side. So we move the minus 5 across. So we're going to get fg of x plus 5 is equal to 2x squared. Then we move across the coefficient 2. So we're going to get x squared is equal to fg of x plus 5 all over 2. If we want x, we move the square across. So we'll get square root fg of x plus 5 all over 2 is equal to x. And let's replace it now. So we're going to get square root of x plus 5 all over 2 is equal to fg inverse. Part 2, show that fg inverse 5 is equal to g inverse f inverse 5. So let's use our right-hand side. G inverse f inverse 5. So we first work out f inverse 5. So let's write the function f inverse x, which we previously got, which was x plus 7 all over 2. So f inverse 5 is 5 plus 7 all over 2. 5 and 7 is 12, 2 into 12 is 6. So we can now rewrite that composite function to be g inverse of 6. And g inverse x is equal to x minus 1, which we previously got. And if we want g inverse 6, that will be equal to square root of 6 minus 1. 6 minus 1 is 5, so g inverse 6 is equal to square root of 5. And we could leave it right there. Now let's work the left-hand side, and let's see if it works out to be the same thing. Then they're equal. So left-hand side says fg inverse 5. Now we worked out fg inverse x already, so let's write that. That is equal to square root of x plus 5 all over 2. fg inverse 5, let's substitute, will be the square root of 5 plus 5 over 2. 5 and 5 is 10, 2 into 10 is 5. So fg inverse 5 is equal to root 5 or square root 5. So fg inverse 5 is equal to square root of 5. As such, the right-hand side is equal to the left-hand side, so we have proven what they've asked us. May 2016, number 9b. The distance time graph shows a 3-stage journey of a car traveling from town A to town C and back to town A. Part 1. State the time of day at which the car arrived at town C. So if we look at where town C is indicated on the graph, and we want to find the time, then we just need to come vertically downwards, and we'll notice that it's halfway between 8 and 9, so the time is 8:30. Part 2. Calculate total time in minutes for which the car stopped during the journey. So if we looked at the journey, we can see it started at A, and the distance increased means it left A and headed towards C from 6 a.m. to 7 a.m. And then from 7 a.m. until 2 blocks away, that's 7:30. So it stopped there for 30 minutes. So we can tell from the graph that any horizontal or flat line means that the car had stopped there because the distance is not changing. This journey stopped at 2 places. It stopped from 7 to 7:30, which is 30 minutes. And then at C, it stopped for 1 unit, which was 15 minutes. So the total time that it stopped was 30 plus 15, which is equal to 45 minutes. Part 3. Determine the constant speed of the car during the stage 2 of the journey. So if we look at stage 2, we could see the distance change from 40 kilometers away until 100 kilometers away. And that took 4 units across, which was 1 hour. So how do we get the constant speed from a distance time graph? Speed is distance moved over time taken. Or we can say it differently. The speed is the gradient of a distance time graph. So speed is equal to the gradient, which is change in y. So that's the change in the distance. It started at 40 and it went to 100. So that's 100 minus 40 over the time taken, which was, it ended at 8:30. It started at 7:30. So 8:30 minus 7:30. So if we work that out, 100 take away 40 is 60. 8:30 take away 7:30 is 1 hour. So 60 over 1 is 60 kilometers per hour. Last part of the question, part 4. calculate the average speed of the car for the time during which it was moving. So, if we look at when it was moving, it moved in stage 1, which is identified on the graph, then it rested, then it moved in stage 2 because the distance is changing. That's how we can tell it's moving. It rested at C, and then it moved in stage 3. So if we want to get the average speed, that will be the total distance moved over the total time taken. So the total distance moved was 40 in stage 1 kilometers plus 60 kilometers in stage 2 plus 100 kilometers in stage 3 over the total time taken. And the total time taken in stage A was 1 hour, plus in stage B was 4 units, which is another hour. And in stage 3, 5 units, which is an hour and a quarter. So that's 1 and 1, 2 and 1 and a quarter, 3 and a quarter hours. So the average speed will be 40 plus 60 plus 100, 200 divided by 3 and a quarter, which works out to be 61.54 kilometers per hour. Notice we're ignoring the time it was at rest because this question is asking us to calculate the average speed while the car was moving. May 2017, number 9A, the velocity time graph shows the motion of a cyclist over a period of 40 seconds. So if we look at the graph, we can see that on the x-axis it's time from 0 to 40, and on the y-axis is velocity, which is given as 10 meters per second. So this is a speed time graph. Part 1, calculate the gradient of part A, OA. So if we want to calculate the gradient of OA, that's from the origin to A, that will be the sloping line going upwards. And to find gradient of OA, that will be the change in the y values over the change in the x values, or some textbooks say the rise over the run, or y2 minus y1 over x2 minus x1, or delta y over delta x. They all mean the same thing. So what we're saying really is like a right angle triangle and say opposite over the adjacent. So if we look at that OA line and we want to get the gradient, then that will be the change in y is 10 minus 0. That's the change in the y values, how much it went up vertically. And the change in the x values will be 25 minus 0. So 10 minus 0 is 10, 25 minus 0 is 25, so we're left with 10 over 25. You could break it down if you want. 5 into 10, 2, 5 into 25, 5, so you get 2/5. Or you could write it as decimal, 0.4 meters per second squared. Any of these will work. Part B, calculate the gradient of AB. And if we look at where AB is on the graph, it's a flat line. And any line that is flat or horizontal, the gradient is 0. Part 2, complete the following statements. The cyclist started from rest, and we could see that at O, where his velocity was 0 meters per second, and steadily increased his velocity by how many meters per second each second? 0.4 meters per second each second during the first 25 seconds. Increasing his velocity per second is another way of asking what is the gradient or the acceleration during that period of time. During the next 15 seconds, where we're seeing from A to B, his velocity remained constant. That is, his acceleration was 0 meters per second, because asking for acceleration in a velocity time graph is the same as asking for the gradient of the graph. Part 3, determine the average speed of the cyclist over this 40-second period, which is the two stages from O to A, the sloping line, and then A to B. So average speed is equal to total distance moved over total time taken. And if this is a velocity time graph, we can find the total distance moved as the area under the graph. So if we think about dropping a line down from B and we look at that shape, then that is a shape with 4 sides and 2 of them are parallel. So that's a trapezium. And in our formula sheet, we have the area of the trapezium. So the area of the trapezium will give us the total distance moved. So let's write that in the formulas. Average speed is equal to a half A plus B by H, which is the area of the trapezium, all over the total time taken. And we can substitute a half times what are the A and B, the parallel sides. So on top, on the flat line A to B will be 15 plus the base is 40 times the perpendicular height is 10, all over total time taken is 40 seconds. And if we put that into our calculators, we're going to get 6.875 meters per second. May 2017, number 9b, part 1. Consider the following pair of simultaneous equations. X squared plus 2xy is equal to 5. So we'll name that equation 1, and that's a curve. And x plus y is equal to 3. And we'll consider that to be equation 2, which is a straight line. Part 1. Without solving, show that the point 1, 2 is a solution for the pair of simultaneous equations. So that means if we substitute x is equal to 1 and y is equal to 2 into equation 1, so let's write equation 1, x squared plus 2xy is equal to 5, and we put in the x and y values, then the left-hand side should be equal to the right-hand side. So there are a couple of different ways to do this. So if we substitute, we get 1 squared plus 2 times 1 times 2. 1 squared is 1 ones are 1, plus 2 2s are 4. 1 plus 4 is 5. So the left side is equal to the right side, therefore it works. Or another way to say that is the point x equal to 1 and y equal to 2 lies on that curve. So let's do the same thing with the straight line graph, equation 2. So let's substitute x is equal to 1 and y is equal to 2 into the equation. So if you write the equation x plus y is equal to 3, and we put in 1 plus 2, and that works out to be 3. So the left-hand side is equal to the right-hand side, meaning that the point also lies on the straight line. So if the point lies on the curve and the point lies on the straight line, it means that the two equations intersect at that point. So that is one of the solutions for the pair of simultaneous equations. Part 2. Solve the pair of simultaneous equations above to determine the other solution. So let's rearrange equation 2. X plus y is equal to 3. Let's make it y is equal to 3 minus x, so it looks like a normal straight line graph. And we'll call that equation 3. And let's substitute into the curve. So let's write the curve, equation 1. X squared plus 2xy is equal to 5. And we can substitute for y from equation 3. So that'll be x squared plus 2x by 3 minus x is equal to 5. And if we expand the brackets, we're going to get x squared plus 2x times 3 is 6x. 2x times minus x is minus 2x squared. And we can bring the 5 across. On the right hand side is plus 5. When you bring it across, it will be minus 5 equal to 0. And why do we do that? Because solving quadratic equations normally is best or easiest done when one side of the equation is equal to 0. So we can simplify x squared minus 2x squared. That will give us minus x squared plus 6x minus 5. And we have a quadratic now, and there are a couple of different ways to solve this now. We can either use the quadratic formula or we can factorize. So if we want to factorize, let's look at the two terms a and c, the coefficient of x squared and the term without x. So that will be minus 1 and minus 5. We don't need the sign, so we just say 1 times 5 is 5. So if we place 5 squares in a line, that will give us a 1 by 5 rectangle. We can't rearrange that to get any other rectangle. So 1 and 5 will be the terms that we're going to use in order to replace the middle term. So we're going to manipulate 1 and 5. We can say plus 1 plus 5, or we can change the signs, plus 1 minus 5, or minus 1 plus 5, or minus 1 minus 5. And let's see which one of them would be able to give us our middle term, which is plus 6. The first one works out to be plus 6, so that works, and none of the others will give us that. So what we're going to do, what we had in green there, that middle term, we'll replace plus 6x by plus 1x plus 5x. So let's rewrite that line. 3 terms becoming 4. So minus x squared plus 1x plus 5x minus 5 is equal to 0. And it doesn't matter whether we write plus 1x first or we put the plus 5x first. We could switch them. It will still give us the same answer. And let's look at the first pair. Let's underline it in maroon. So minus x squared plus 1x. Can we factorize that? Well, what can we pull out? We can pull out minus x. And that will be left with x minus 1. And let's double check. Minus x times x, minus x squared, minus x times minus 1 plus 1x. Let's bring up a purple line under the other pair, plus 5x minus 5. And if we want to factorize that, but we want to make sure that we end up with the same brackets, x minus 1, then what can we extract? We can extract plus 5. So now When we look at our line, what's the same? The brackets x minus 1 is the same in both of them. So we can factorize that out. So we write x minus 1, and what is left? Minus x plus 5. As such, either x minus 1 is equal to 0, so x is equal to 1. But if we look at part 1, we already have that solution, x is equal to 1. So we're looking for the other solution, which will be the second brackets. So if we look at minus x plus 5 is equal to 0, that means if we carry the minus x across, that means 5 is equal to x. So the second solution includes that x is equal to 5. And if we substitute x is equal to 5 into equation, let's look at 1, 2, or 3. Equation 3 looks the easiest. Then let's write that y is equal to 3 minus x. And y is equal to 3 minus 5. So y works out to be minus 2. As such, at the point 5 minus 2 will be our second solution, meaning the second point where the straight line meets the curve. May 2018, number 8a. The diagram shows 6 points of the function y is equal to 3x plus 1 over x. The coordinates of these 6 points are given in the table. So we have x and y, and we have the point 0.1 and the matching y term for it, 0.2, and we're missing 2 terms, 0.5 and that 2. Complete the table by calculating and inserting the missing values of y. We're missing a term when x is equal to 0.5, but we have the equation, so let's write the equation. Y is equal to 3x plus 1 over x, and let's substitute. So y is equal to 3 times 0.5 plus 1 over 0.5. 3 times 0.5 is 1.5, plus 1 over 0.5 is 2. So that gives us y to be 3.5. So let's bring that up in the table. So we got the first point. And let's do the same format for the second point, when x is equal to 2. So y is equal to 3x plus 1 over x. 3 times 2 plus 1 over 2. 3 2s are 6 plus 0.5 is 6.5. So we could bring that up in the table as well. Part 2 says, on the diagram, the ordered pairs shown in the table have been plotted, except for the missing ones. Because if you notice, we have 6 points plotted on the graph, and we have 6 points, both x and y, in the table that was given. Using your answers in A part 1, that's the other 2 points that we brought up, plot the missing points and connect all the points with a smooth curve. So let's bring up the first point that we plotted, 0.5. That's exactly halfway between 0 and 1. So there are 5 blocks there between 0 and 1, so 2.5 blocks. And we bring up the point, 3.5. And then x is equal to 2 and y is 6.5. And let's draw our curve. Part 3. By drawing an appropriate straight line on the diagram, find approximate solutions to the equation 3x plus 1 on x, which is y, that's our curve, is equal to 6. It means that if we consider we have 2 equations, one being a curve, 3x plus 1 on x, which we already have plotted on the left-hand side, and on the right-hand side, we have 6. So let y be equal to 6. So if we draw that line, y is equal to 6, and we're comparing where the straight line meets the curve, those 2 points of intersections will be our solutions. And the point on the left-hand side, it's 0.19 for the x value, and of course, the y value is 6. And on the right-hand side, it's 1.8, and the y value is still 6. May 2018, number 8b. The speed time graph below shows information on the first 60 seconds of a car's journey. So if we look at the graph, we can see that there's a straight line for stage A, where the speed was 0, meaning that it was at rest, and the speed increased until it reached 15 for the first 40 seconds. And then stage B took over, where from 40 seconds to the next to 60 seconds, the speed increased from 15 meters per second to 40. Part 1. Calculate the acceleration in meters per second squared of the car during stage B. This is a speed time graph, and the gradient of the graph is the acceleration. So gradient of stage B, MB, is change in y over change in x, and the gradient is the same as acceleration, which is, what's the change in y? 40 minus 15 is equal to 25, 60 minus 40 is equal to 20, 25 over 20, 5 into 25, 5, 5 into 24, 5 over 4, which is 1 1/4, or 1.25 meters per second squared. That's the acceleration of stage B. Part 2, calculate the average speed of the car during stage B. So if we look at stage B and we have a constant acceleration there, then the average speed will be just finding the initial speed, let's call that U, and the final speed, adding them up and dividing by 2. So average speed is equal to half of 15, that's the initial speed, and the final one is 40. 15 plus 40 is 55, 2 into 55, average speed is 27.5 meters per second. And the last part of the question, part 3, at time t is equal to 60 seconds, which we have at the end of stage B, the car starts to slow down with a uniform deceleration of 2.5 meters per second squared. So deceleration means that the gradient is negative. Determine how long it will take the car to come to rest. So if we consider the gradient at stage C, which is not on the diagram, that will be the change in y over the change in x. It will be a straight line because it has a constant or uniform deceleration. And we can substitute. If we substitute, the gradient or deceleration is minus 2.5. The change in y, it's starting at 40 meters per second and ending at rest at 0. So the change in y will be 0 minus 40 over the time taken, which we don't know, and that's what we want to calculate. So we can carry the t across because it's dividing, it's a denominator, so it'll go up on top. And we can bring it minus 2.5 below, so we can write t is equal to minus 40 over minus 2.5. We have two numbers with the same sign, so that will be a positive. And 2.5 into 40 is 16. So the time taken to decelerate until it reaches a stop will be 16 seconds. This brings us to the end of CSEC past paper questions in the topic of algebra, relations, functions, and graphs, which were combined in section 2. In our first video in this series, we looked at the past paper questions for the first 5 years, 2009 until 2013. In this video, we looked at the next 5 years, 2014 to 2018. So our next video will be from 2019 until the present. Don't forget to look at the description down below so you can get a better understanding of the entire CSEC Maths syllabus.